Alright, what up guys? It's me. Welcome to another episode of Squid Game in Unity. Now, for those who don't know what Squid Game is, it is a series made by Netflix in 2021 where contestants compete in a series of games for a big money grand prize. So, the game that we are playing, or that we're making, I guess, is the Squid Game. This is going to be a tough one to make. I'm not entirely sure how I'm going to do this off the top of my head. The rules for this game are there are two teams, offense and defense. Defense can run on 2 feet within the bounds of the game, while the offense has to hop on 1 foot outside of the lines of the court until they successfully pass the neck of the squid. In the final battle, attackers must rush from the entrance to the squid and attempt to tap the top of the court with their foot. If someone is pushed out of the court, they die. But if a player manages to get to the top of the squid, they are victorious. A coin is flipped to decide which player is offense or defense. Yeah, that's gonna be tricky to make. A warning that I just give in front of every one of these videos. This is just for fun. This is not being published. Netflix, please don't come at me. The way this is going to work is I'm going to make a rough draft of the game with functionality. It just doesn't necessarily look great. And then I'll go back after that's done and make a fully working version with like fancy graphics and something that could actually be a downloadable game. And at the rough draft, I'll take a break from developing, come back, walk you guys through the scripts and everything, and then make the rough draft. The final draft. So, we are in Unity. We're gonna play the game, and we're gonna tap Squid Game, and here's our blank scene to get started. So I will see you guys once I have a finished rough draft. What up, guys? I now have a rough draft of Squid Game. I will say I did have to use AI for just thinking about how to do this and planning it through, but I'm going to walk you through the rough draft and then also the scripts and what went into it. So, with that being said, let's head over to Unity. So, if I hit play, as you can see, we are playing as the attacker. We have a defender. Also, hopefully you guys enjoyed the French Open on in the background over there. But we are playing as the attacker. We have a defender that just kind of roams around and chases after us. So, we're gonna do 2 run-throughs of this, right? So, this one, we go out of bounds, and as you can see, we have this message here that says, you lose. Now, if we start over, this may take a couple tries. You can see we stick to the rules of the game, and then we hit the head of the squid, and we hit this message that says, you win. So this one did have to be keyboard controlled. I've tried to do touch controls on all the other ones, but unless I'm dividing the screen into zones, and then even then it's a little bit difficult. And again, the sake of this is not a fully functioning, published game. The sake of this is to, have fun. So, because I'm not publishing this, it makes it a little bit easier on me to just do WASD for controls. So it is a very rough draft. In the last couple, I've tried to stick to very little materials, and it's the final draft where I go through and essentially feed the image into Claude Code and say, hey, here's what it looks like now. Let's make it look something similar to the actual show. But that being said, let's hop into the scripts. So we have 4 scripts for this. To start with the game manager, we have the instance, and then we have a Boolean variable saying the game is not over. So on start, we define instance as the specific script, which allows us to access this script from other scripts and essentially modify something like game over on a collision from the player. Update, we don't need, and then we have 2 functions that will be much different in the final draft. We have player out of bounds and player wins, and essentially it just sets game over to true each time, and it sends to the console, you lose or you win. We move on to the player controller. So we have our move speed, and then we have our hop speed. The way the Squid originally was, there was a little bit of a gap. So there was a gap that I would have to hop over. That's why hop speed was there, but eventually I just shrunk it down. We then have our rigid body, and we have our current zone, which defaults to tail because that's where the player starts. Then on start, we define our rigid body as the component that is attached to the game object that this is attached to. And then we have fixed update, which means it updates every couple frames. I explained that in a different video, so go check that one out. But then we have a loop that says if game over is false, which means the game is still going. We get H, which is our horizontal axis, and V, which is our vertical axis. We then define 2 vectors. We have our camera forward and camera right. We then set the Y's of each of those to 0, and we normalize those vectors. This helps with the camera offset. This makes it look a little bit more natural, because there was an offset before. When you would hit A, it would keep going for a while the camera caught up. This just offsets that. It was a little bit easier to do it with the player movement than to just, do it on the camera follow. We then set the direction to forward times vertical plus right times horizontal, and we normalize that. We then define speed, and we say that the hop speed, I got confused. So the point of the game is certain areas of the squid you have to hop, certain areas you can use both feet. Hop speed is a much slower speed because you're moving on 1 foot. Move speed is the full speed because you're moving on 2 feet. So we just define that. We say that if we're in the tail or the waist, we're on hop speed, and if we're in anything else, we are on move speed. We then set the position to that times direction times speed times fixed delta time. We then do a little check to see if we press space, which moves us forward. Again, that was for the jumping motion, which is no longer needed. We then check if current zone is empty, which means we are out of bounds. We hit player out of bounds and the game ends, we lose. If we are in the head, we say the player wins, and that pops up the you win message, which will eventually be like a GUI in the final version. We then have our last function, which is on collision enter. We check to see if the game object is squid part. We're using .compare tag. You could also use equals here. And then we're setting current zone to the game object name. And if the collision does not have squid part on it, we then set current zone to empty, which means we are out of bounds. Moving on to our defender. We have the player, which is the target. We then have patrol speed, chase speed, and detection range. For these, we have, and then we also have our rigid body and our patrol target. So to start, we get the rigid body. This is attached to our defender, so it gets the defender rigid body. And then we set a new patrol target, and we'll go through that in a minute. In our fixed update, we check if the game is over. If it is not over, we define distance to player as the distance between, well, the current position of the defender and the player position. We then check if the distance to the player is less than the detection range, or essentially within the detection range. If it is, we move towards the player at chase speed. If it's not, then we move towards at the patrol speed. And if we're close to our patrol target, we then get a new patrol target. So move toward. We take in a Vector 3 target, and we also take in a float for the speed. We then define a Vector 3 called direction, which is just our target position minus our current position, and we normalize it. We then set direction, the Y direction, to 0, because we're not moving in the Y direction at all. And then we tell the rigid body to move to that position with speed times time.delta time. And then lastly, setting new patrol target. Our patrol target is now set to a random range between 2 and -2 on the x-axis, 1 on the y-axis, and between -1 and 5 on the z-axis. And lastly, we have our camera control. We're defining our target, and we have our offset, and then in late update, which refreshes, I'm not positive on this, but it refreshes after all of the movement, which is why we had to account for that lag. We're setting the current transform.position to target position plus the offset, and then we're having the camera look at our target. So that is the rough draft. I'm going to go ahead and create the final draft, and I will check back with you guys once I have that created.
Do you hear that? My sanity about to break while everyone I know's out. On a trip, on a boat, on a lake. I'm tired of feeling all FOMO, babe. I don't even care if we stay home. Put our to-do list on ice. We crank the AC to 79 and make a little island right here. And there ain't a palm tree in sight, but there's not a cloud in your blue eyes.
Alright guys, I am back with a final working version. Or it should be working at least. Okay. Yeah, I'm back with a should be working version. So let's go take a look at the final draft. Now, just a warning, my computer does not like this for some reason. So fair warning. But same mechanics, and then if you lose, you get bumped off like you would in the show. We have this panel that comes up, we then have a restart button. I made the court look a little bit more like it actually is in the actual, like it is in the actual show. But then if you win, you have a you win, and you can restart. So I'm gonna walk you through the scripting changes. There really wasn't many. We added variables for win panel and lose panel, and then instead of logging win or lose to the console, we just have it so that now it opens up the lose panel or the win panel. There wasn't any changes in player controller. The only change in the defender script was this push force, which down here we have on collision enter, we check the game object name, then we have push direction, which is the player position minus the defender position, and we normalize that. We then set Z and Y to 0, and we normalize it, and then we add a force to the player's rigid body that is the push direction times the push force with the mode of impulse. Now the only other camera controller we didn't touch, the only other new script is this torus mesh. There's not a built-in torus mesh within Unity. So the way we handled that was by creating a mesh via a script. So we have our outer radius, our inner radius, our sides, and our rings. So to start, we get the mesh filter from the cylinder object, and we set it to the result of generate torus. Now generate torus is a function that returns a mesh, and we are defining a mesh as a new mesh. We then have a vector3 array of vertices that is the size of rings times size, which in this case is 24 for both of those. So it's a 576 wide array. And then we have an integer array called triangles that is an integer array of 6 times that amount. Don't ask me why it's 6. We then come down here, we say for integer r is equal to 0, and r is less than rings, we increase r. So it goes through 24 times, because rings is 24. And we're saying ring angle is equal to, and we're casting that as a float, so it probably naturally wants to return a double, but we're making it a float. Where that's inside another for loop for the sides. So we have r and s, which is ring and sides. Now we're setting the side angle to s divided by sides times pi times 2. Then we're setting x, z, and y to, or we're setting x and z to the cosine and the sine of this angle, but it's outer radius plus inner radius times this cosine times the cosine of the side angle times the cosine of the ring angle. Then we are setting z to the radius math times cosine of sine angle times sine of ring angle. Excuse me. And then we are setting y to the inner radius times the sine of the side angle. And then we are assigning one of those indexes in vertices to be that vector. We then come down here and we have t. We set it to 0. We then go with r and s again in the same logic. Then we have current next, and next. And this basically goes through and updates the triangles for each individual side. And then down here, we set the mesh.vertices to be the vertices, we set the triangles to be the triangles, and we have it recalculate the normals, and then we return the mesh. So that is the biggest change. Again, camera controller, we did not touch. But yeah, that is the final product of Squid Game. So guys, if you liked this video, be sure to subscribe, leave a like, leave a comment, do all those things. The engagement really helps get the channel out there. And until the next video, I will see you guys in the next video. Bye.